Hello, I'm Lazarus. I'm going to be teaching you the topic 4.2 real zeros, or how to find real zeros of polynomials. So let's begin. Now, a zero of a polynomial is the point on the graph where x can be any number, where y equals 0. So say for this equation, x squared plus x minus 6, the two zeros here are -3 and 2. Now, there are a couple of ways to find these zeros, and graphing isn't always the best option, because there is a bit of information that graphing glosses over, and we'll get to that later. But for right now, I'm going to show you how to solve it using the first method, factoring. Now, the other main method to do this would be the quadratic formula, but that isn't really necessary as these are clearly factorable integers. So for x squared plus x minus 6, we would have to factor it out into two different factors because the degree of the polynomial is 2. Every polynomial has a number of zeros equal to its degree, in this case 2. So for factoring, there are a couple of different ways to factor, but the way I like most is synthetic division, as it works for many degreed polynomials, such as x to the 7th, or even further, and it usually ends without a hassle. So the only problem is you usually need the first factor, which we have here on this graph. You can see the first factor, -3, and so we'll begin by taking out the -3. Now, for factoring, when you have a factor, the factor isn't just going to be a -3, because the factor needs to equal 0. Now, whatever the second factor is doesn't matter, because at this point, -3 in this factor is going to equal 0. So you have to add 3, because when x equals -3, it becomes 0, and multiplies by whatever the other factor is, and turns the whole thing to 0. And that's why factoring is very effective. So for the case of this, we will have an x plus 3, and we will be removing it from this polynomial here. Now, for synthetic division, you need to take the factors that are in front of each number in the polynomial, or the coefficients. You would start with the x squared, which would have a coefficient of 1, because this x squared is really a 1x squared. The 1 just isn't shown. And you would have the same here. It's plus 1x minus 6. Now, for synthetic division, you bring down the first value because this highest degree is being multiplied by an x, and it isn't affected by this 3. So this would be a 1x in your factored form. So you multiply the 3 by the 1x to get 3x. And you have to remove the 3x from this final value of 1x to find out what you would get for how many x's you have to multiply to create this 1x from a 3x that you get from this. So the x times this value would be combining with the 3 to create a 1. Anyway, that's why synthetic division works. Back to the equation at hand. 1 minus 3, -2, this should be your final factor. And this coefficient should work with this coefficient to create the constant here. And if you multiply them, you'll see that that is the case. 3 times -2, -6, subtract it, it becomes 0, so your remainder is 0. So the two factored forms of this equation is x plus 3 times x minus 2, which you can see from the graph, your two zeros would be -3 and 2, as supported right here. Now, on to our second example. This graph looks a bit different because, as you can see, the degree is 4. However, it appears that there are only 3 zeros here, -3, 0, and 1. There is a specific reason for that, and I will talk to you about that when we get to it. let's synthetically divide out from our equation like we did the first problem. We have x to the fourth plus x to the third minus 5x squared plus 3x. Now, our first factor, negative 3, would give us, again, x plus 3. And when we factor it out of the 1x to the fourth, 1x to the third, negative 5x squared, and 3x, we can also put a 0 in the constant place, because it's good to always keep every place, even if there's nothing in it. So we bring down the 4, or x to the fourth, to be an x to the third, a 1x cubed. And we are going to then multiply by our constant for our factored form. We get 3. Subtract the 3 from the 1. We get a negative 2x squared. Multiply negative 6. Negative 5 minus negative 6 is really negative 5 plus 6, or 1, which is 1x. And then our 3 times 1x is a 3, which we then subtract to get plus 0 in our constant place. And then 3 times 0, 0, subtract 0 from 0 is 0, and that all cancels out. So our final factored part of this equation is x plus 3 times x cubed minus 2x squared plus x. Now, this equation here is one we are going to need to factor again in just a second, using the other part of this graph. You can see our next factor out is 0. Now, in order to factor out a 0, you would need an x plus something that equals 0 when you put in 0. And you do not need to add or subtract anything from 0 to get 0, so your factor would just be x. Now, in order to factor out an x, here you can see all of these are multiples of x, so you would just divide by x, or have x squared minus 2x plus 1 because of this 1x. And you have that times x. That is your next step in factoring this particular equation. Now, for the final factors, that didn't work. For the final factors, we have a 1. Now, we are going to have to take this here and factor out a 1. So you'd have x minus 1, like before. Factor out from the 1x squared, negative 2x, and 1. Bring down the 1. Negative 1 times 1 is negative 1. Subtract negative 1, adding 1. You have minus 1. Negative 1 times negative 1 is positive 1. Subtract it for a remainder of 0, and you get x minus 1. So your factored form of this would really be x minus 1 times x minus 1, or x minus 1 squared. And this is why it appears as only 1 0 on the graph, because it is really shown as 1 0, but only once, even though it is shown as 2 separate factored zeros. This is called multiplicity, which is however many times a 0 occurs in a particular equation. So with graphs, you can't really determine the multiplicity. So it's not always the best to use a graph to find your factors. However, there is a neat little rule for multiplicity that isn't really pertaining to anything for finding the zeros, but the multiplicity can sort of be determined. Is that if the line crosses the x-axis and continues on in the other direction, it has an odd multiplicity, say a multiplicity of 1 or 5 or 3. But if it comes towards the line, reaches it, and then returns in the first direction, like with this, it has an even multiplicity, a multiplicity of 2, 4, etc. And you can take a few steps to determine the multiplicity from the graph, but it is best to just factor it out and figure it out from there. Now, for our final example, this equation here. Now, if we look at the points here, we have -3, -2, 0.414, 0.414, and 1. Now, these two middle zeros are going to be a bit tricky because, as you can see, they are irrational numbers. Even though this graph doesn't really show them as irrational, they do repeat forever. It just rounds them down to the nearest thousandth. These irrational zeros are another thing you can't really determine from graphing. You need to factor out through the equation. And you would normally be unable to find it using synthetic division. However, we do have some integer zeros which we can remove using synthetic division first. So we have our equation of x to the fourth plus 4x to the third minus 8x. Oops, that's not a 3. Minus 8x plus 3. And we are going to start by factoring out this zero, -3. And that would be an x plus 3, like before. -3 plus 3 is 0. And you would be factoring that out from a 1, a 4. Now notice, we do not have an x squared, but we still need to keep the placing for synthetic division. So we would put a 0. It's a 0x squared. -8 in the ones, and 3 as our constant. Now, we, like before, bring down the x to the fourth to be 1x cubed. 3 times 1 is 3. Subtract from 4. That leaves with 1 again. 3 times 1 is 3. Subtract 3, you get -3. 3 times -3 is -9. Subtract -9, which is adding 9, to -8, which is plus 1. And then 3 times 1 is 3. Subtract from 3 to get a 0 remainder. So your final factored form would be x plus 3 times x cubed plus x squared minus 3x plus 1. That's a bit difficult to read, but it won't matter because we're going to be factoring it out soon enough anyway. So we factor out our equation, and then we have to remove another factor, the 1. So we have, again, x minus 1, because our 0 is actually 1. 1 minus 1 is 0. We bring down our coefficients, 1x cubed, 1x squared, -3x, and 1, and then we divide like before. We have our 1, -1 times 1 is -1. Subtract a -1 is really adding 1, or 1 plus 1, 2. -1 times 2 is -2. Subtract -2 is adding 2. -3 plus 2 is -1. -1 times 1 is 1. Subtract 0 remainder. So we have x minus 1 times x squared plus 2x minus 1 as our next factored part of this equation. So we would be using that to replace this. So we have x plus 3 times x minus 1 times x squared plus 2x minus 1. Now this is where it gets a little tricky. When you look at these zeros, they're irrational, so you can't really factor them out using synthetic division or something else. That would be very difficult. So instead, we use the quadratic formula, as it is a second-degree polynomial. Now the quadratic formula uses the form ax squared plus bx plus c. And the formula itself is used to find quadratics that equal 0. So to find our solutions, we would use -b plus or minus the square root of b squared minus 4ac over 2a. Now, when you plug all these numbers in, with 2 being b, 1 being a, and -1 being c, you get 2 squared minus, that's squared, minus 4 times 1 times -1, or just minus -4 plus 4, 2 squared plus 4, 4 plus 4, square root of 8, negative b, or negative 2, over 2 times 1. So you have negative 2 plus or minus the square root of 8 over 2. And the square root of 8, using rational rules, can become 2 square root of 2. That isn't really anything important for the video, but in the end, you have negative 2 plus or minus the square root of, well, 2 square root of 2 over 2. And all of these things are divisible by 2. So you can factor it out again to be negative 1 plus or minus the square root of 2. And if you look in the graph, negative 1 plus the square root of 2 is 0.414, which is our 0 here. Negative 1 minus the square root of 2 is 2.414, which is our 0 here. So our two zeros that we have not found yet are negative 1 plus the square root of 2 and negative 1 minus the square root of 2. Along with these two, our 1 and our negative 3, we have all the zeros of this graph. Now, I've gone a little bit over time for this video, but I think it won't matter because I've covered everything I needed to. I hope you've enjoyed, and I hope it has helped you understand finding the zeros of polynomials a little more. And that's about it. Thank you for watching. Goodbye.